Welcome. In this video, I'm going to discuss how we can use graphs to determine how two variables are related. Now, keep in mind, your math teacher would do a much better job of explaining how these relationships work and how these graphs are produced. I'm doing the best that I can with what I know to meet you where you are and with what you know in terms of math. So the first thing is we've got to get our data plotted. So hopefully you've watched the videos, you've made your graphs, and now you're looking at how to interpret those graphs. So when we have a direct relationship, you see the quote in the middle of the screen there, as one variable increases, so does the other. So on this graph, inches of rainfall is increasing here. This isn't a great graph because it doesn't have labels, but I was trying to keep it simple so that you could get a model of what you're looking for. So as the rainfall increases, the sale of umbrellas also increases. So that's a direct relationship. As one goes up, so does the other. So if you make your graphs and you see an almost perfect straight line with a positive slope, so increasing to the right, that's probably a direct relationship. Again, it doesn't have to be a perfectly straight line. There's going to be a little bit of variability depending on how well you did your range and scale calculations. An inverse relationship, you see my rule of thumb there, as one increases, the other decreases. So whatever our x-axis is here, it's increasing and the y value is decreasing. Again, it's pretty much a straight line. Another way that we can see an inverse relationship is if we graph 1 over y, like we're doing in the Boyle's Law lab, and if we see a straight line there with a positive slope, that would be an inverse relationship. So a negative slope with just graphing x and y, or a positive slope with x and 1 over y. The last one we should see the least, and that's a power relationship. If you've graphed x squared, that's what we're seeing here. This is obviously not x squared. This is x to the negative 4th, and this is x to the negative 6th or something like that. But we've got these curves where there are two lines that don't meet. That's what we're looking for when we see a power relationship, so the graphs don't match up. We shouldn't really see any power relationships today. I just wanted to show that one because that may come up eventually down the line. So that is how we can use graphs to determine how variables are related.